So we've looked at basic trigonometric identities, we've looked at solving equations. Let's put the two things together and use identities to solve equations. So we want to solve this equation. 4 sine x equals tangent x for x between 0 and 2 pi. Now you might notice that there's a sine of x and a tangent of x. A basic strategy in solving equations with trig functions is get it so that the equation only has one trig function. And what we know is that tangent of x can be replaced with sine over cosine. So this equation becomes 4 sine of x equals sine x over cosine x. And now we have this cosine x in the bottom. We don't like variables in the denominator. So let's get that out of there. Let's multiply both sides by cosine x. So it becomes 4 sine x cosine x equals sine of x. Now you might see the sine x on both sides and be like, oh, I want to divide by sine of x. But remember, we can't divide by the variable to get rid of it. The strategy here is to get all the terms to one side and then factor. So we have 4 sine x cosine x minus sine x equals 0. And both terms have sine of x, so we factor that out. And now we use the zero product property. We know that sine x equals 0, or for cosine x minus 1 equals 0. And from here, we can find the values of x that make this true. So let's start with the more straightforward one, sine x equals 0. What values of x are going to give us a sine that's equal to 0 between 0 and 2 pi? Well, that's going to happen when x equals 0, when x equals pi, and when x equals 2 pi. So we get 3 solutions from that part. Now, the second one, 4 cosine x minus 1, let's come up over here and work. So 4 cosine x equals 1. Divide by 4. Cosine of x is 1/4. So now 1/4, that's not on our unit circle, so we're going to use inverse trig. X equals the inverse cosine of 1/4. Now, putting this into our graphing calculator, we will find that x is approximately 1.32 radians. Remember, we need to be in radians here. So 1.32 radians, that is a first quadrant angle. Where else, which other quadrant is the cosine going to be positive in? Well, the cosine is going to be positive in quadrant number 4. And the quadrant 4 angles reference off of 2 pi. So if I draw a sketch here, here's the 1.32 that we just found. The fourth quadrant one will be 1.32 that direction. That is less than 2 pi. So another solution would be x equals 2 pi. It's supposed to be a pi. Bear with me. Minus 1.32, or approximately 4.97. And remember, when you are using approximations, you need to be giving these answers to 3 significant digits. So we got 3 solutions down here, and we have 2 more right there for a total of 5 solutions to this problem. Here's another equation. Solve 2 sine squared theta plus 3 cosine theta equals 1. And theta is in the interval, it's an element of negative 180 to 180. So we're working in degrees. And the smallest solution we can give is negative 180. The biggest is positive 180. And you look at this and you go, oh, sine squared and cosine. That's ugly. I don't want to deal with that. Well, unfortunately, you have to. But we can change sine squared so that it's not sine squared anymore. Because remember, sine squared plus cosine squared equals 1. And if I do a little bit of rearranging, I can take that cosine squared, move it to the other side, so sine squared is alone. So sine squared x is the same thing as 1 minus cosine squared x. And I can then take that and substitute it. So let's look at the implication that has. So 2 sine squared becomes 2 times 1 minus cosine squared plus 3 cosine theta equals 1. Let's distribute. We've got 2 minus 2 cosine squared plus 3 cosine theta equals 1. Now, this happens to be a quadratic, and if you don't see that real well, you could use a substitution here and say that let t equal cosine theta. So we have 2 minus 2t squared plus 3t equals 1. How do we solve quadratics, ladies and gentlemen? Well, you should be saying, get it equal to 0, get it equal to 0. You're right, that's what we do. So let's get this thing so it's equal to 0. We get 2t squared minus 3t minus 1 equals 0. That's just rearranging it, getting all the terms to one side, and I like my squared term to be the positive one. So how do we solve this, guys? Well, the way we solve this, is it factorable? Let's try. 2t and t it would have to be minus 1 and plus 1. Does that work? I hope you're saying no, that doesn't work. So we're going to need to use quadratic formula. We get t equals opposite b plus minus the square root of b squared minus 4 times ac all over 2a. So jumping up here, t is equal to 3 plus or minus 9 plus 8 is 17. And it's over 4. So we'll get two values for t. T is approximately this. T is approximately that. But remember, it's not really t. It was cosine. Cosine x equals those two values. And if we use inverse trig now, what we will end up getting are our angles. And the two values that we get when we do this, when we put this in our calculator, when we approximate this, we get that cosine, and I put an x here instead of a theta. Hope you're yelling at me and screaming at me right now. We need to stay consistent with the variables that we're using. But cosine theta equals 1.78, or cosine theta is approximately negative 0.281. So now we're going to do inverse trig, inverse cosine 1.78. Well, that's not possible. That's greater than 1. Forget that one. That's out. That's junk. That does not help us whatsoever. But the inverse cosine of negative 2.81 0.281, we get an approximated value of 106 degrees. So that would be that angle there. If we then find other angles that have that cosine, that negative cosine, we're going to be looking at that angle. That angle has the same cosine value. It's in the third quadrant though. So we need to think about the reference angle. What is the reference angle for 106 degrees? The reference angle for 106 degrees is 74. It's 74 degrees away from the x-axis. So that means this green angle that I drew is 74 degrees underneath the x-axis. But remember, we're calling this negative 180 at this point. So what's our other answer? Our other answer, I hope you're thinking to yourself, well, it's negative 106 degrees. And that, ladies and gentlemen, is where we stop for today. These equations get a little bit more complex. Give yourself room, and we're going to be okay. You need to be able to manipulate the equation and ideally get equations that have only one trig function.